page, which is this is our agenda or the topic that we will learn for today, which is we will learn introduction, what is DC circuits examples, type of circuits, formula, and also we have a practice. So okay, take a look for page 3, which is the introduction. Direct current circuits, which is DC, is a current which flow in one direction only. All the battery produce direct current. That means there is no change of magnitude of the current. In other words, it's also called steady direct current. Okay, what is DC? For example, you can see at the picture where the charges flow in one direction only, and the battery an example of a direct current sources. So, okay, that's the picture. The picture and series circuits explain. You can see that the battery is the direct current source that we use in direct current. At the bottom, you can see they also have series, parallel, and series. I will explain later. So take a look for the example. What's the device that use the DC is flashlight, cell phone, and also our laptop. And then also the charger. All of the charger for this device, we also use a direct DC. Because when we want to charge the device, we want to charge all these devices that we have, we need to direct charge in the switch. So take a look for page 6. So what I said before, which is we have two types of circuits. The first one is series circuit, and also the second one is parallel circuit. For the series circuit, connection is a type of multiple lot connection that allows a single path of charges to flow. But it's different for the parallel circuit, because the parallel circuit, a connection that has at least two or more complete path or loops for flowing charges. As you can see, take a look at the picture that I already attached the picture, and you can see the differentiation between the series circuit and also the parallel circuit. So for the circuit, current flow through a closed circuit as a loop with no break, but an open circuit as a break and stop the current flow. This is for the open circuit. So take a look for the page 7. So this is also the comparison between the series and also parallel circuit. So they both of them have a closed circuit, but for the series circuit, not common in home. The parallel circuit is commonly used in home. So the third point is unreliable wiring method. So series always have not an unreliable in the explanation, but for the parallel, we also it also reliable method of wiring because we use it at home, right? Like in our class. Also we use the direct circuit. So for the fourth point is failure affect all device or bulb. But for the parallel, failure does not affect all device or bulb because it's direct to the material, the things. So take a look. For next, this is also the explanation of the type of the circuit. So there are several options for connecting multiple lots in a circuit. Here are two of the most common approaches, which is the series and also the parallel circuit. So for the series circuit that we can many connections to connecting all of the circuit. Okay, this is formula that we will use, which is under the Ohm law formulas. This is the formula that we will use in the calculation later. Okay, this is the a brief explanation of the Ohm law that describes the relationship between the electric current and voltage in conductor, stating that the amount of electric current flowing through a conductor is directly proportional to the voltage that is causing the current to flow. So, what is I? I is a current that measured in amperes. V is a voltage that measured in volt. R is resistance of the conductor that measures the ohms. Okay, so divided V by R to find the current, and divide V by I to find the resistance. This is the clue. So okay, as you can see the picture at the left picture, which is DC on low charge. This is the division that we have to divide the formula to I think this is the easiest way to remember which formula that you need to use in your exam or your calculation. So for the parallel and series, they also have own formula. So yeah, as you can see, for the capacitor, resistor, and also the inductor, they have their own way how to calculate each of the circuit. So okay, last but not least, we have the Q&A session. If you have before we go through with our practice, if you have any question you want to ask, you may ask. Okay, all of you understand what I said before, right? So can we jump direct to practice question? Let's go. Okay. Any question that you want to ask or you don't understand, you can ask. Okay. So, okay, guys, and you can finish to the question. Solve the question. If any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So, any question that you want to ask or you don't understand, you can ask. Okay. So here we need the main fan, the switch, the battery, the connector, the pin connector, and also the motor or the mini DC motor. So you can do this experiment in a group. So one of the battery switch, also this fan, and then so first, okay, connect the pin connector to the battery. Pin connector to the battery. Okay. You need to press hard. Okay, now connect the mini fan with the small DC motor. Can you press a bit? Okay, it's okay. Okay, now connect all the wire to the connect the pin wire to the switch first. Yes, take the switch and then connect to the switch. You need scissors. So it's a bit hard to connect it because actually the switch is off before you want to connect. Okay, you have to try it. Just put in and then just it's not connected. It's not connected. Little careful, it's hot. Okay, question already done and also experiment. Okay, so our lesson for today is already done since you guys can answer the question and also you guys also already done the experiment. So for our chapter for today, it's finished here. Thank you, students.
Thank you.